Okay, so of all the 4 demos that we have here at Brooklyn 6G Summit from Nokia Bell Labs, the one that I really want to show you is the AI and what AI can do for future networks in 6G. I mean, as one of the first in the industry, we have shown what AI can do for the air interface, the handset and the base station, figuring out the most optimal communication. And we've actually demonstrated in the real proof of concept that you can do 30% better than classical digital signal processing. So this is one of the demos that we have through this interactive screen here. Another demo that we showed last year already is natural language model networks, using natural language models to auto-configure the network. The most obvious one is a human telling the network what to do through the application programming interface. But it's actually also the network functions themselves. They've been specified by humans. And so using natural language models, we have found a way to automatically figure out how these different functions can work together. And then there's a third thing that I want to show here, and that is how do you achieve interoperability in this new paradigm of AI? The AI from different vendors that have to interwork with base stations from different vendors. And we want to do this in a way that you avoid that you have to share the algorithmics, AI models, the architecture, because that's the secret sauce of the companies. And we found a way to do that, and we collaborated with Qualcomm to prove that you can do it. And for that, I actually want to hand it over to the principal research engineer on this, Karl Nussmann.
In this collaboration with Qualcomm, we wanted to demonstrate interoperability. If you think about most AI, it happens in one place. One company designs it and implements it. But in this case, we're doing a compression. We have information at the mobile device that needs to be compressed and sent upstream to the network device and decompressed. And both of those pieces are AI, and they need to work together. So in this case, we can't design it all in one place. So we developed this technique called sequential training, where the network vendor first designs the end-to-end AI and then just shares a designed data set with the mobile device vendor, who's able to, in a second step, train a compatible encoder that speaks the language of that decoder. And we did that training step, we tried it out in practice, and found that it worked just as well as if we had designed it together, sharing all of our proprietary implementation details.